my name is Aga, and I'm one of the TLs on the Android Wear support library.
And I'm Ollie Lan. I'm the lead engineer for watch faces on Android Wear. It's great to be here. We're excited to tell you about some new things to help you build apps and watch faces on Android Wear. I'm going to introduce some tools to help you build watch faces with support for complications. But first, Aga's going to tell you about some big changes coming to the support libraries for Android Wear.
Thank you. So when smartwatches first launched, a lot of developers struggled to build apps for this new form factor. There were issues with small screens, round screens for the first time, and also bridging information from the phone to the watch. We built a wearable support library to help with these issues, and today I'm pleased to announce that we are starting to open source our code. The wearable support library will be moving to the Android support library and will become the so-called Wear module. This is similar to other modules in the Android support library, ones that hopefully you already know, like the Core UI or the Recycler view or design. So we will just become another module for you, again, open sourcing the code. This is launching with Android Support Library 26.0 Beta 1. So it launched actually 2 days ago, so you can start using it pretty much immediately. It's very easy to add to your code. You just add your regular dependency with a very similar structure to other modules. Just make sure to mention Wear there and Beta 1. So hopefully this change makes you happy. There's a few reasons to be happy. First and foremost, as I said before, the code is now open sourced. You can stop trying to reverse engineer it now. It's all going to be out there. The APIs will now be part of the support library, and they will be consistent with the rest of Android and the rest of the support library. We will have more frequent releases along the Android support library. That will be roughly every 2 months. And this means we will be able to take in more of your feedback and react to it a lot quicker than we were before. But we won't be moving all of the code at once. That would be a bit of a shock to the ecosystem to move everything. So we'll start with the UI components, and I'm going to focus on that for the rest of my talk. So the first package we will be open sourcing is the View package, or now it's going to be called the Widget package. And there we want to focus on enabling round-friendly UIs and space-efficient interaction patterns. So we're targeting the two main issues that developers had with UIs, which is building stuff for round screens for the first time in Android, and also building for really, really tiny screens, very little screen estate. It's not trivial to build good UIs in such conditions, so that's why those are the things we're focusing on first. Here's a good example of how we've enhanced a typical Android list. You used to have on Android a very straight list. All the elements would just go one by one, start at the top. What we've done with Wear here is we've played to the round factor of the watch. We've adapted the list to follow a curve, and that means also it fits a lot more information on the screen than it was able to with just a straight list. Here are some other examples of our best round-friendly UIs. We've got the launcher. We've got the date time picker, launched recently in the new Desk Clock app. And then we've got LiveSum, which is a great example of a third-party app that encompasses a round-friendly UI. So all of these make use of the curvature of the screen. All of them manage to fit more information in the UIs and are just generally more pleasant to use. So these are the kind of UIs that we want you to build in the future, and we want to help you build those UIs with the support library. So when building the Wear widget module, so the UI components, we were thinking of the UI generally in terms of components. Much like Android Framework, much like the Android support library. So with this module, we want to develop a suite of building blocks that would make it easier for developers to put together a UI which is both intuitive and feels native on Android Wear, as well as build it in a flexible manner enough that it will kind of express the personality and the character of your app. So we're exploring both tiny building blocks, like views, so image views or text views. We're also exploring larger ones, like the wearable recycler view or swipe dismiss frame layout. And we call these specifically components. And these components, this larger pieces of data, and you come together to form UI. So this is where you come in as developers, and you will reuse our components and views to build your own apps. Okay? Some of these views and layouts already exist in Android, and some of them need to be implemented specifically for Wear. Those are the ones that we would want to go to put in the Wear module in the widget UI library. So here's a visualization, again, of how we think about UI. It's reusable building blocks rather than custom tailored or special case interfaces. Hopefully that's not big news to you, but I wanted to make it very plain that this is what we're going for with this new library. So again, with this in mind, we hope we will enable you to build good interfaces, functional interfaces, very rich ones, that feel native to Android Wear, but also express the character of your app. So this is quite a long project. The complete construction of the Wear module will take some time, so I wanted now to spend the rest of my time to talk a little bit about how we will make it happen and what's the timeline for it, kind of step by step. So we have divided all the existing Wear UI elements, broadly speaking, into 3 categories. We will migrate the components that are already built for Wear and that are Wear-specific into the new Wear module. Some components we will merge. Those are the components that are useful not only for wearable devices, but also for handheld devices. So they can be reused on phones. And there's no need for them to live only in the wearable space. So we will kind of graduate or merge them into the framework or into other handheld or generic support modules. And then the last group is the components that we will deprecate. Those are the ones that are mostly associated with old design patterns that have not proven successful with our users. And I'll talk a little bit more about that in a second. So first, I want to talk about the components that will migrate. I want to kind of shine a spotlight on them. Those are the most important bits. They are the ones that are launching with the Support Library 26 Beta 1. And that's the wearable recycler view, which gives you that nice curved list that we used also to build the launcher. Then we have the box inset layout, which enables you to fit all of your UIs on the screen into the center middle square of the screen. So you can reuse basically your UIs between a square and a round watch. And then we've got the swipe dismiss frame layout, which is quite an interesting case because it encapsulates a design pattern that we want you to use. So this pattern is replacing the back button on the handheld device. On Wear, we don't use the button for a back gesture. We want you to swipe away your views. That was a specific request from the developers during our developer preview program. So we're making this component available to you in the wearable support module. The next group, so in terms of code, should be really simple, short slide. On the example of the wearable recycler view, this is how you import it now into your code. And this is how you would use it in an onCreate method in the activity, for example. So now with the migration to the new module, there are very few changes that we would need from you in terms of code, hopefully very simple and easy to implement. So first, we changed the package name to support Wear widget to distinguish this new UI Wear module in the support library. And then the second thing is that we would introduce minimal tweaks to the API so that it is consistent with the existing Android APIs and support library APIs. These are better APIs, and hopefully will make your code healthier in general. So super easy to update your apps. Really not much of an issue. Clicker. OK. So then some classes, the ones that we're merging, are not only applicable to Where. This we will, as I mentioned, merge into the main framework or different support library modules. So here we've got mostly kind of what I call round things with an icon inside sometimes. There's a lot of them. All of them look the same. There's no point in having separate UI components for it, separate kind of pieces of layouts that you would need to use. And also, there already is a circle image view in the support library for handheld. So we're going to take all of those additional APIs that we've created and merge them into that one component so that there's only one kind of really strong, really flexible component for you to use. And then the third group, here I want to talk about it on this example of a conversation in Hangouts, is a group of layouts that we're deprecating. So those are the layouts that are associated with user patterns that didn't prove successful, didn't prove popular with our users. So here we are taking the two-dimensional spatial model, where you could move either vertically or horizontally in an app or in the system UI, and we're transforming it into a linear layout, like here, just vertically, which is which is following the material design principles. So all of the classes associated with that two-dimensional spatial model will be deprecated. So that's the grid view pager, that's different action buttons, action layouts, things like that. So this will hopefully slim down your dependencies as well. That pretty much encompasses everything that we're going to be doing in 2017. And here's a rough timeline of what I've just been speaking about. So today we're announcing and launching the Where module with the first 3 core components. Just again to remind you, that's launching with the Android support library 26.0 beta 1. When that program graduates out from beta alongside the O launch, we will deprecate the old APIs in the current place, and then we will really encourage people to move over to the new APIs. Then we will subsequently have regular bug fixing and update releases of the Where module with the Android support library. And then sometime, say, mid-2018, mid-next year, we would be starting to remove old APIs so that we slim down, again, dependencies to the ones that we want people to use. So that's all from me. With that, I'm going to hand over to Ollie to talk about complications.
Thanks, Saga. Some important changes there. So I'm going to talk about some new things we're adding for watch face developers. And as this is a big win for anyone building a watch face, yes, it's another reason to jump in the air in front of a sunset. More personalized, helpful watch faces are a key part of Where 2.0. That's why last year, here at I/O, we introduced the Complications API for Android Wear. On Wear, just like in traditional watchmaking, a complication is a display of data on the watch face. So these are all examples of complications. Apps using the Complications API can be data providers, or they can be watch faces. And Android Wear manages the flow of data between the two. So watch faces using the API can be configured to show any of the data providers that are installed. This lets users put the information they care about just a glance away. And if you build a data provider, you can get your app's data onto a whole range of watch faces. All of these apps already include data providers for complications. There's fitness apps, like Strava. There's finance apps, like Robinhood. And there's weather apps, like AccuWeather, and lots of others. So if you add complication support to a watch face that you're building, users will be able to choose from any of these apps if they're installed, as well as from built-in providers like the World Clock, Next Event, and Battery Life. It's like you're adding functionality from all of these apps without having to know a thing about them. Many watch faces have already added complication support, including classic-styled ones like Ultimate Watch 2, more abstract styles like Venom, and super customizable ones like Pugy Black. And there are ones that are a bit different. On Move from the US2 Moods collection, the ring around the outside is a complication. So here it's showing your battery life, but it could also show your fitness progress. Mesh Turbine HD shows the complications on spokes coming out from the center of the screen with a scrolling text effect. And FitCat, it has a cat. But it also has complications using the API in their own style. So there's a huge variety of styles of watch face on Android Wear. And that's why the API gives watch faces complete control over how they draw the data, to ensure complications fit perfectly, and to allow new, interesting ways of representing the information. But this freedom can make it hard to add complication support to a watch face. When you build a watch face, you don't have access to layouts or views. You draw directly onto the canvas. And you have to create the settings UI yourself. Today, we're introducing a few things to make this easier. There's Text Renderer, which helps draw all kinds of text onto a canvas. Complication Drawable is a complete rendering solution for complications. A new settings sample shows how to let users easily configure complications and style. And a test suite provider lets you easily check if complications will display correctly. So first up is Text Renderer. And you might have noticed this has been in wearable support for a few months. Text Renderer makes drawing text onto a canvas easier. And that's important because many of the most useful complication types include text, such as the short text type, the long text type, and the ranged value type. The strings in the short text and ranged value types will be short. They should only be 7 characters maximum. Whereas in long text, the strings can be any length. And there are challenges rendering the text in both cases. So here's a short text example. This string here is 7 characters long, and it fits nicely at this font size. But this string is also 7 characters long. So to handle both of these and make them fit, you have to measure the text before you draw and adjust the font size accordingly. Here's a long text example. A short string looks good centered vertically. But the text can be any length, so it can easily flow outside the box. You can use something like a static layout to help with this, but you need to be careful not to relay out the text on every frame. With Text Renderer, you tell it the bounds that you want the text to fit in. If 7 characters don't fit, it will shrink the font until it does. And longer text can be flowed over multiple lines and ellipsized at the end. So let's look at some code. So when you initialize your watch face, create a text renderer using this simple constructor. And you pass in the text paint that you want to use. The text paint defines the font, the text size, the color, things like that. Now, because Text Renderer caches things like the layout, you should create one for each field. So we have one for the text here, and we also have one for the title. Don't share text renderers between fields. Now, when you want to draw, you need to set the text on the renderer. So you do that calling setText, and to get the text, you call getText. Now, this takes the current time. And you need to do this every time you draw. And that's whether you're using text renderer or not. And that's because some complications are time dependent. So imagine a world clock complication. The text changes depending on the time. Once you've set the text, draw into the bounds that you specify. Now, it's OK to pass in the text and the bounds every time like this, because text renderer only lays the text out again if something has changed. That does mean that sometimes you need to tell text renderer that a change has occurred, such as if you change the paint's text size. And that's because the paint is a different object from the text renderer. So let's imagine that we have code that makes the text bigger when something happens. In that case, you should call request update layout on the text renderer so that it can adjust. Now, one other thing that text renderer can do is adjust the rendering for the always on screen, so for ambient mode. Many watch faces are black and white in this mode, so you might not want things like color emoji appearing. So you need to tell the text renderer that the device has entered ambient mode. So in on ambient mode changed in your watch face, you just pass the in ambient mode Boolean into the text renderer like so. So that's text renderer. We strongly suggest you use it whenever you're rendering text directly onto a canvas. But what if you want not just text, but the entire complication drawn for you in a standard way? That's where the new complication drawable comes in. Complication drawable can render all of the 6 main complication types, and it handles all of the layout and styling for you. As an example, let's look at what you'd need to do to render a short text complication like this. Now, without complication drawable, when data arrives, you need to decode any of images which are included. And you also need to cache those images, because you certainly don't want to decode them more than once. Now, every time you draw, first you need to check that the data is active. And that's because some complication data is only relevant within a certain time frame. For example, if it's for your next meeting, you don't want to show it after the meeting is finished. And then to draw, well, we draw the background, we draw the image, and we draw the text, probably using text renderer. With complication drawable, it's much simpler. When data arrives, you pass it to the drawable by calling set complication data. And then on every frame, you just call draw. It is a drawable. Now, like text renderer and like other drawables, complication drawable draws within bounds. And the layout adapts to the shape of the bounds. So here you can see within square bounds, you get a circular complication, whereas the wider bounds give a pill shape. And you can also see that the position of the icon is different in the 2 cases. If you don't set any style parameters, you'll get a default look. But there's many things you can set, such as the background color, the corner radius, if you'd rather have something more like a square than a circle. You can change the border or have no border at all. You can change the colors, and you can change the typeface. You can create a complication drawable programmatically with a simple constructor. And then you can set styling options for active mode and for ambient mode. But if you have lots of styling to set, you might find it easier to use XML instead. You will need to be using API level 24 to do this. But as long as you're doing that, now you can just inflate the drawable in the standard way. Now, we do need the context to render, so you'll need to pass that into us as well, into the drawable. And if you do that, then your XML might look something like this. So attributes at the top level apply to both ambient and active modes, unless they're overridden in ambient mode by the attributes in the ambient section. So there are a few things you need to pass to the drawable. As I mentioned earlier, you of course have to give it the complication data. So in onComplication data update for your watch face, which is where you receive the data, you just pass that data to the drawable. You also need to tell the complication drawable when the device goes in and out of ambient mode. And that's because the drawable handles the change of styles for you. So all you need to do is call set in ambient mode every time it changes. And you also need to tell the drawable if there are any special properties of the screen. So if it uses low-bit ambient mode, or if it has burn-in protection, tell the drawable that, and it can adapt the rendering for those properties. And then to draw, now, if it's the first time or if something's changed, then you'll need to set the bounds. So set the bounds, and you just call set bounds on the complication drawable. Now, the bounds that you pass in here should be defined in proportion to the watch face bounds. So you might say, position it 1/4 of the screen width across. Don't use fixed dimensions, and that's because watches vary hugely in their size, so you don't want to be defining things in an absolute way. Then you could just call draw on the complication drawable. This method also takes the time, and that's so it can get the correct up-to-date value. So that's it, complication drawable. So that should really make it a lot easier to add complication support to your watch faces. Now, complication drawable is the biggest addition to wearable support, but the next two things are available as samples so that you can adapt them to meet the needs of your watch face. The first is for settings. Any watch face with complications should include a way to configure them, and usually that's in your watch face settings. But if you bury complications deep in your settings UI, it can be frustrating for users who want to change things around. For the LG Watch Style and Sport, we worked with our partners us2 to design an UI that lets users have a visual interface for setting up complications and also have quick access to other settings. So here's how it's set up. At the top, we have an image of the watch face with the complication slots clearly shown. This lets users get a good idea of where the data is going to appear. Provider icons show what's currently selected in each slot. Below, if you scroll down, you can see all of the other settings. Now, background image here is a special case. Technically, it is a complication using the large image type. But in studies, we've found users understand this better as a separate item. So this is what it looks like on the portions watch face. And now let's see it in action. So you'll see the user can just tap on one of those slots at the top. It opens the complication provider chooser, and they can quickly choose what they want in each slot. It's much easier than having a list with left slot, right slot, top slot, etc. If you'd like to try this on a real watch face, download the us2 Looks or Moods collections on any watch running Wear 2.0. All of those watch faces use this UI. Now, you'll find this UI implemented in the updated watch face sample. So check out Analog Complication Watch Face Service in the sample. This has been updated for the new stuff that we're introducing today, so it also uses complication drawable now. The config UI is in Analog Complication Config Activity, and the items that are shown in the UI are defined here in Analog Complication Config Data. Let's take a quick look at that class. So in here, you'll find this method, getDataToPopulateAdapter, and it returns a list of config items. So those define what the entries in that settings list are. So the top entry will probably be the preview and complications config item. That's the view of the watch face with the slots. And then we might have a background option. We might have some more options, and then return. The actual sample has a few more details than this. So that's settings. Now let's say you've added complication support to your watch face. How can you check that everything's working? For most complication types, there are several combinations of fields that you must handle. So for example, if your watch face supports short text complications, that might be in the form of an icon with text, or it might be a text and another piece of text, or just a single piece of text. The Test Suite provider makes it easy to make sure that every combination looks good on your watch face. So when you install the test suite, it'll appear in the list of data providers. And when you pick it, you'll be able to choose which complication type you want to test. So let's say we choose short text. Here's how it might appear on the watch face. And then all you have to do is tap the complication, and it will cycle through the different combinations. So all of these are short text complications. And if your watch face supports short text, it has to render all of these correctly. This is a long text example, and for long text, there's even more combinations. So it's really useful to give this a go and check that everything works properly. You can have icons with text and title, just text and title, or images as well. We're releasing the Test Suite Provider open source on GitHub so that you can see how it works and so that you can add your own test cases if you want. If you're building a data provider and not a watch face, I suggest you also take a look at this, because it's a good example of a provider for each of the different complication types. So that's it. So these 4 tools should make it a lot simpler and easier to add complication support to a watch face. Please do give them a go. There are code labs to try out here at I/O, or you can check out the samples on the dev site or through Android Studio, or you can start using the new version of Wearable Support and try it out on your own watch face right away. And please do let us know what you think.
So this is just one last slide that sums up our presence, Android Wear presence at Google I/O 2017. If you haven't seen the talk yesterday at 9:30 a.m., it is recorded. It was a general overview of how the platform is doing and what's new in the platform this year. And today's talk is also recorded, so you can come back to it after I/O is done. Thank you very much.